Hello everyone, welcome to the course Data Structures. This is Thulasi Chitra, Associate Professor, Department of CSIT, MLR Institute of Technology. And in the previous session, as we have discussed about circular queue ADT, as that is a part of types of queues, let us discuss in this session what is this priority queues, right? We will be discussing about what is priority queue. What is priority queue and what are different types of priority queues we have, and what is priority queue ADT, and we are going to see the priority queue implementation. So, the four things we are going to discuss in today's session. What is a priority queue? Why we need to go for priority queue other than this normal queue or circular queue, right? In normal queue data structure, what happens is insertion is performed at the end of queue and deletion is performed based on the FIFO principle, right? And this queue implementation may not be suitable for all applications, right? From the front we are going to delete and from the rear we are going to insert, and this will follow the principle of FIFO, first in first out principle, where it is going to follow. And this will not be suitable for all the applications in our real time. And let us see what happens in priority queue. Priority queue is also a variant of a queue data structure, right, in which insertion will be performed in any order of arrival. In which order you are going to get, in that order you are going to store that in queue, right. Suppose I have inserted 12, 5, 4, 7, 9, like this way I am going to insert, but deletion is performed on the priority. Based on the priority we are going to delete them, right. This is the main difference you are going to find with normal queue and this priority queue, right. And here when you are going to see about these priority queues, these are classified into mainly two types. One is min priority queue, where you can find the representation of a queue in the form of ascending order, ascending priority queue, and other one is max priority queue, where you can see this representation in descending priority queue. Let us see with the example how we are going to represent this min priority queue and max priority queue. In this one we will implement only with small change, you can implement the other one also. Let us see what is min priority queue is. Here the collection of elements in which the elements can be inserted arbitrarily, but only the smallest element can be removed first, right. You can insert the elements in any order, but here it is represented in the ascending order, right, and from this the smallest element is going to be deleted first. That means the smallest element is having the highest priority and the largest element is having the lowest priority in the min priority queue. And the order also, if you could check, the order is in ascending order, increasing order, the elements are going to be stored. Either you can store them in an increasing order, and based on that it will be storing in the least element will be stored in the first priority place, so that you can delete accordingly. Otherwise you can store it in any random order, and based on that also you take the priority for it, give the priority for it, and we can delete it, right. This is one way. And max priority is where you can insert the elements in any order, but the largest element can be deleted first, right. These two methods are there. Here the highest element is present and this is representing in the descending order. Highest element is at the first position and the least element is at the last position, right. And in priority queues the elements are arranged in any order, and out of which only the smallest and largest element allowed to be each time, or element are going to be deleted each time. This is one way we can do. Otherwise we can insert all the elements in either max priority or min priority representation, and we can implement it any of the method, okay. And the best way of implementing the priority queue is normal way, by using arrays and linked list we can implement, but the best way of implementing this priority queue efficiently is by using the heap concept, right. This one we are going to see when you are discussing about the sorting. There, by using this heap we are going to perform the priority queue and we will represent the heap priority. That is heap sorting we are going to do, right. That can be done efficiently by using this priority queue efficiently, right. Let us see what is priority queue ADT. Here We know that data part is having the elements, you can give the priority, otherwise we can store them based on min priority or max priority representation, and the different operations where we can perform or NQ, DQ and display operations, right. And how we can implement these priority queues? We can again, as we have seen in queues as well as in circular queues, here also we are going to implement these priority queues using array, by using array representation as well as in linked list representation. And let us see how we are going to perform NQ operation in priority queues. Here I told you, we have discussed there are two major operations that can be performed on priority queues, that is insert and delete. These operations can be performed like this way by using the NQ operation. Here, while implementing the priority queue, we will apply a simple logic. What is that logic? While inserting the element itself, we are going to insert in the proper position. We are inserting the elements in the proper position so that it will be stored either in the min priority representation or max priority representation, right. So that it is very easy for us to delete the elements with the min priority or max priority. In the min priority, low element is having the higher priority, in the max priority, higher element is having the higher priority, right. Based on that we can represent, and here it is representing the max priority representation. The first element which I am going to insert is 12, we do not have any other element to compare, that is why we are going to directly insert the element here. And the second element I am going to insert is 9. In this case, it will be comparing with the first element, it is the least element, so that it is inserted at the position Q1. Now, when we are inserting it, rear should be incremented. From the rear only we need to insert the element into the queue. And if you could see this, now I want to insert the element 10 in the queue. So, in the first position already we have 9. I told you we need to insert based on its position, that is representing its priority also. 12, previous example, 12, 9 is there. Now I want to insert a 10, where I need to insert? In its position I need to insert, that means I am going to move 9 here and 10 will be inserted here. In the same way, if I want to insert 11, I am going to move 10 and 9 and I am going to insert the element 11 in this position. Right. Now, how I am going to do this? This will be similarly like our queue, but only a small condition will be included in this priority queues. Let us see the same condition we have seen, rear equal to size minus 1, where it is going to have the priority queue is overflow, and if front and rear are equal to minus 1, in this case also we are going to initialize front equal to rear equal to 0, and by reading the x value and by inserting that in the rear position. And when you are going to insert the second element, first element you do not have any problem. From the second element onwards, we need to check whether we are inserting in the correct position or not. For that, we are going to write the check case. Then let us see what is going to be written in the check case, right. And after inserting the element, we need to insert, we are going to increment the rear value. Right, that is why we are doing this. Now go for the check case. What is happening in this check case? Let us take the same example which we have taken previously. Let me take the third element I want to insert. I want to insert the element 10. Now this is 0 and this is 1, right, and this is my front value and this is my rear value. Let us see how this is going to work. How this 10 should be inserted in this position and 9 should be at index 2. Now just check this logic, how this is going to work. J equal to 1, 1 greater than or equal to 0, condition true. If you are, what is your data value to be inserted? Data is this one, data is 10, right. Data value is 10 greater than or equal to PQ of J. J is nothing but 1, right, in the rear element, that is, right. In PQ of J, what is the element? You have 9. Yes, 10 is greater than or equal to 9. Now what we are going to do? We are going to place PQ of J in J plus 1 position. PQ of J, whatever the element you have, right, this is PQ of J value, that is going to be placed in PQ of J plus 1 value. In this position, we are going to place it, right. And then now what happens? Now what happens? Your J will be decremented. J becomes 0, 0 greater than or equal to 0, condition true. Now, again it will be checking for the data value. 10 value is greater than or equal to PQ of J value. J value is now 12. 10 is not greater than or equal to 12. Now it will be coming to the else part and your loop will be terminated. This will be terminated. Now PQ of J plus 1 equal to data, right? What is your J value now? PQ of J value is 0, 0 plus 1 equal to data value is 10. In PQ of 1, that is here, we are going to insert the element 10. Now you are going to have 10, 12, 10 and 9 will be present in your list. Like this way, we are going to insert the element at that correct positions by using check function. That means here we need to write two functions. One is NQ function and another one is that is check function. After inserting the element, we have written one more statement here, check off. After this, we are going to increment rare plus plus. Right? This one also we need to represent here. Now this is not rare, rare should be incremented, rare becomes this. Right? This is your check function. Then how we are going to perform the deletion? By using front only, we are going to delete the element. Just increment the front value and the remaining cases will be the same as your Q. Right? Front equal to -1 and rare equal to -1, your that is an underflow condition. Front equal to rare, we are going to delete the last element, that also becomes front equal to -1 and rare equal to -1. Let us see. These are the same cases where we have implemented in our Q also, right? Display is as usual for displaying all the elements in the queue. That's why I have not represented here. And the overall summary, what we have seen in this priority queue is, we have seen what is a priority queue and types of priority queues we have seen. Then what is priority queue ADT also we have discussed, and then priority queue implementation we have seen, right? In two ways we can implement priority queue using arrays and linked list, and in that we have seen the max priority queue. If it is greater than or equal to, it is a max priority queue, and if I am going to represent less than or equal to, it will be printing you the min priority queue, right? This is about the priority queues. If you have any doubts or any comments, please do comment in the session. Thank you.